Okay. Um, this is the more hidden gotcha kind of improper problem. This is going to change your integration life to have to be a little more careful. Okay?
Oh, I was hoping it was change our life.
No, it's for the worse. It's now you've got a trap problem in there, and you have to be very aware of not falling into the trap. I'll explain. So imagine if you had 1 over x squared, and you talked about the region right of x equal 1. It would look like this. Okay? Okay. If I wanted this area, we've been talking about how technically the limit is 1 to infinity. But we create an arbitrary right endpoint and let that grow without bounds is the proper way to go about that, yes? Do you agree? At this point, most of you are beyond the integration errors that come with this. For example, assuming that everything is a log just because it has a fraction, which is ridiculous. What's the antiderivative of x to the negative second?
Negative 1 over x.
Negative 1 over x from 1 to a. Depending on if the curve decreases fast or slow, it might converge, it might not converge. In this case, does this converge or diverge? This converges and the area is 1 unit. Okay? 1 square unit, excuse me. Now, today's topic of the day is if you were to take this curve and shade above y equal 1. In fact, you know what? That's what I was afraid of. I was afraid of Joe saying use symmetry, and we're not going to use symmetry. So instead, shade the region left of x equal 1. Now you can't use symmetry. Yeah, I can. I can just add 1 to the symmetry. No, not there. Okay. No, it's not. It's not 2. It's not 2. All right, it's 2, but it's not always going to be 2. So the idea is this. This feels like a fine integral from 0 to 1 of 1 over x squared. It's not obviously improper, and yet it is improper. Why is it improper? Yeah, it's not continuous at x equals 0. That is the second form of improper integral. If for example, you tried to integrate 1 over x squared from negative 2 to 2, there's a big old integral in there, or a big old asymptote in there you have to be aware of. So now you have to check for continuity is the point of this. There are 2 types of improper integrals now. Should we continue on and show that this is 2, or no? Can you view that? Sure. Yeah, I feel like, I don't know. All right. All right. If the interval is infinite. All right. One type of improper integral that we've been doing since 126, I think, is if you have an infinite limit or an unbounded region, usually on the right side, but it could be on the left side. In that case, nobody fails to identify that as improper. It's staring you right in the face. It says infinite. Nobody forgets that one. These are the gotchas. If there's a discontinuity, there are 3 types. Would you draw yourself a little doodle here?
I love doodles.
Yeah. So one possibility is if there is a discontinuity at the left edge of the region from B to here. Now, if that's the case, then you create an arbitrary endpoint, they're calling it K, and say what happens as K gets closer and closer and closer to the asymptote. Notice it's from above. That's going to happen when you have a left discontinuity. It is also possible that you have some kind of discontinuity at the right. I'll call it D, and A, and A. If that's the case, then you would create some kind of arbitrary edge point K and say what happens as K gets closer and closer to B from below. Okay? The worst possible case is if there is an interior discontinuity. If you're going from A to B, and there is some kind of interior discontinuity at C, say it looks like this, well, then that stinks because now you're going to have to do two integrals. One, creating a cut point from below as K approaches C from below. And another one, is that a J? J as J approaches C from above. What happens? All right. So many possibilities. Be aware of this kind of deal because if you are just mindlessly plowing ahead using your magical calculator, and if you were to type that into your calculator, what's the problem here? Joe, nice, Joe.
No, I did not hand that. Okay, Alice handed it to me from.
Okay, so anyway, if you mindlessly plowed ahead, threw this into your calculator without recognizing there was a discontinuity there, the Inspire will often give you a questionable accuracy warning saying, hey, you better check yourself before you rest yourself. If you have an old school 84, I don't think it even knows. I think it just blows up. So,
Just like blows up.
yeah. So, check this out. Tell me how you would set this up. Now that you're going to check for continuity first. Is it continuous over the interval? No. So, we're going to let, what do you want to let approach what? A, not X, that's ridiculous. A approaches 0 from above or below? Above of the integral from A to 4 of x to the negative half. Okay? Anti-differentiate. What is the antiderivative of x to the negative half?
Root x.
Root x times?
Root x times 2. Negative 2.
That's positive 2.
Oh, yeah.
Okay. So we get something like the limit as a goes to infinity of 2 root 4 minus 2 root a.
Wait. Yeah, you said infinity.
Yes, 0 from the right. Sorry. So, does this integral come out finite or infinite? It is
It's finite.
finite. 4 minus 0. It is finite.
Let's see what happens if I plug them in later.
All right. Try the next one on your own.
I accidentally put beads. Oh, it worked on the calculator too. Like, if you plug it into the calculator.
So hopefully you're finding you have a discontinuity at 0, which is the right end point, the right edge. So you're going to approach the right edge from below. So you let the limit as a goes to 0 from the left. Negative 1 to a of e to the x over e to the x minus 1. I would, if at all confused, I would probably do the antiderivative off to the side. What's your technique for integrating that? use of.
Oh,
It's 1 over u straight up. Do you agree? Nothing, no funny business? So natural log of the absolute value of u, which is natural log of e to the x minus 1 is the antiderivative, right? So yeah, no,
you want the absolute.
the absolute value probably has to be there just in case.
Is that what? Oh, there. I don't think you can do that.
Hey, so let's see how this goes. I get natural log of e to the a minus 1 minus natural log of e to the negative 1 minus 1.
It's the negative.
What is e to the a approach as a approaches 0?
It's 1,
1 minus 1 is
0.
0. And so log of 0 is obviously no go, so we need to talk limits now. It's not actually log at 0, it's log of approaching 0. As you approach 0, what is the log approach? Negative infinity. So this is negative infinity. What about combining them? Can I combine those into a single log? Is this indeterminate? What's this equal to?
The natural log of
Something. It's
negative
finite. Do
1
you agree?
plus 1 over e. It's just not a function.
It's something. It's a finite number, right?
Yes.
It's not infinite. So is that indeterminate or divergent?
It's a divergent.
It's divergent. Okay. What? Oh, that has nothing to do. Sadly, I watched that version and it had 0 calculus. What a letdown. That was what? It'll be great. You'll love it. Okay, so here we go. This one. What's the problem with the next one? The problem is the discontinuity is
Well, it's in between.
inside.
That's so hard.
Inside. If you're a picture person, go for it. But if I want to go from 0 to 4, I'm talking that kind of deal. So you'll need 2 integrals. The first one, let's let A approach what?
You want a to
1 from the left and from where to where?
from 0 to a.
0 to a of 1 over x minus 1 dx. And then we need another limit of b, I guess, approaching
B approaching 4. Or I mean B approaching 1 from the right.
1 from the right,
From B to 4.
oops, from b to 4 of 1 over x minus 1 dx. Okay, so here we go. The limit as a goes to 1 from below of the natural log of the absolute value of x minus 1 from 0 to a, plus the limit as b goes to 1 from above of the natural log of the absolute value of x minus 1 from b to 4. Okay? All right? The limit as a goes to 1
My A looks
from
like it.
below natural log of a minus 1 minus log of 0 minus 1 in absolute value, plus limit as b goes to 1 from above of natural log
There.
of 3 minus natural log of b minus 1. We?
Yeah, it's a little too fast for us.
Why?
You
You're,
have
yeah,
your
you're
go.
young. You're supposed to be go.
No, but
Yes. Why it goes to what? Yes. So you cannot
I
integrate.
think we have enough room.
So there's an asymptote at 1, and you can't integrate up to and including the asymptote. So I'm letting A be a point just below that one, and say what happens as that line gets closer and closer and closer to now I have a B on the right hand side. Okay, so here we go. This guy. This approach is what?
0, but from like -1.
This is natural log of 0.
Very small though, so it's gonna be negative.
So it's very small. So this is going to
Negative.
-infinity. This is 0. That's fine. And this guy. So the log of 1 is 0. Log of 3 is 3. And what about log of b minus 1?
Also negative infinity.
Also -infinity. Now, here's the dealio. This is indeterminate. It is -infinity plus infinity. And that's all there is to it. You cannot deal with it. You cannot combine those in any way. It must be indeterminate. Or divergent, actually, because it fails to converge. But you cannot put these two together like you sometimes can because they're different limit statements, right? You cannot put the limits together. Okay, would you try the next one or 2 on your own?
Which one are we doing?
The second one over. You do not have the tool set. You have not seen all the ugly cases. You need to. I do not waste your time. All these are chosen for a reason, so do it. Really. You'll figure out, oh, I'll do this, so I'll do that. Choose these for a reason. And that's all meant to advance your learning in some way.
Okay, so here's what happens with little freshmen. You bring them to the pig and you bring it to so I like bounced over. And then I was upset because then I
It
was
is not calculated, by the way.
and then he turned around and I did more than and then I felt that turned around right away.
How do you find where's the -1 is 1 minus 2 is 3. Joe, where's
Part of this is a technique question. You should not be using your calculator.
I just don't know where the asymptote is.
So how could you find it? That's the question.
I was trying to factor it out, but and then it's just
Now what do you do? Is that the only way you have to find zeros?
quadratic formula.
Here's my thing.
So you're lucky she's holding you back.
Or you could complete the square. Okay, that's actually the best basic thinking question. It's not just like being handed, I regurgitate what you taught me. It's a question that you get, in fact, it is a question from a placement test on a calculus exam for college.
I would not.
Sure that I don't think
Is Newton's law -1 plus 5 over F?
Newton's, oh my word, how would you be using Newton's method?
To find a 0.
Quadratic formula, dude.
That's what I was saying, but then Joe said use Newton. Joe? I said use quadratic formula, and then Joe said Newton's method.
I was.
Or you complete the square.
Joe, why are you like this?
And I mean that.
So there's no real roots, right?
Yeah.
Okay, now whether you use quadratic formula or complete the square like I did, you should be able to know I mean, geez Louise, you're a Calculus 2 student. You should be able to know if a quadratic formula problem has a root or not. So it doesn't have any real roots. What does that imply about continuity?
It implies that there's like.
If there are no real zeros, then there are no places the denominator is
Equals 0.
0. And therefore, there are no
Well, or
asymptotes, no discontinuity. So is there any reason you can't just straight up integrate this?
yes, or I mean, no, there's not.
No, you're fine. There's no improper integral. Now, the second reason I use this question off that exam is because I don't think that most of you could integrate this properly.
Thank you.
How would you do it?
Complete the square and trig sub.
You would have to complete the square and possibly trig sub, or maybe just know it's Archimedes. Yep. So, Alex, you would have done it.
Alex, you're on the right now.
I know, I just say a bunch of things.
Joe,
What?
Mom, if I do, we can't do that. Really mean feelings.
That's what it should look like if you were to complete the square. That is a pretty nice, it's not a nice problem, but in terms of the trig sub, it's not even really have to be trig sub. You could just see that's the what?
Tangent of
Inverse,
x plus 1.
inverse tangent of x plus 1. And so it'd be something like arctangent of 1 minus arctangent of
I know.
0, yes? So your answer is?
I over 4.
5 over 4 is the answer to that problem on that exam. All right, now that said, this one is like it, but slightly different. This
As an asymptote.
does have an asymptote of
X equals negative.
double root at -1, so there is a limit component to this. The limit as x goes to a goes to -1 from above or below? Above. I'm going to write this as x plus 1 to the -2nd instead. And so the limit as,
So then you can take like.
what is the antiderivative?
Whoa!
Chills.
What's the antiderivative?
1/3 x plus 1.
That's the derivative. Why is there a third?
Oh no, I just did it the wrong way. I thought it was
-1 over x plus 1, yeah? Okay. So the limit as a goes to -1 from above of -1 over 1 plus 1 over a plus 1. As a goes to -1, the denominator goes to 0, 1 over 0 goes to infinity.
So which way?
And yeah, so which way is right? It's a little above, so like -0.9.
So that's gonna make it positive.
So it'll be positive, so I feel like positive infinity. This is infinity or divergent, depending on which multiple choice
Infinity minus 1.
would be there. Okay? All right, often you'll see instead of a multiple choice saying divergent, you'll see infinity or negative infinity to force you to get into and do the problem. All right, last but not least, this has two problems to it. It has discontinuity on the left and an infinite bound on the right. This is what students want to do. They say let A go to 0 from above and B go to infinity, and that is most definitely not a thing. Okay, this is not something you do. You never do a double, no. Okay, it is not how it's done. Instead, this is how it's done. Imagine here, if you're talking this region, you need a limit going to the left, and you need a totally separate problem for the B going here. And so in cases where there's problems on both, you manufacture or create an arbitrary middle.
You can do like any number you want.
And you can do whatever you want. You can go from A to 1, you can go from A to 10, A to 5, 100, whatever you want.
What about like
So, I'm gonna go A there, 2. Would be the limit as A goes to 0 from above from A to 2, if I use 2. And then add that to the limit as B goes to infinity when I go from 2 to B. That's how you would do it properly, and then you do the calculus and cha-cha-cha. Okay? That's proper work. Okay. That is that. Questions on last night's homework? Actually going over the rest of it. Most of you have this done, yeah? 8? 8.
And then 6 was group.
Okay? 8. What else? 16. 15. Okay. 12. 12. Okay, are we ready? 8. What test did you try? Integral test. That's pretty good. Try a direct comparison test. Focus on the larger powers. So, and I'm not sure if this will play, but let's try it. This feels like 1 over n to the 3 halves, and I'll ignore this part.
Oh no.
Now, would this converge or diverge? That's a converging. And so if I could show, oops, I said less than, but I meant to say versus, okay? So if I could show that this is less than this, then I would be golden, because it would be less than 5. Okay, so let's try that and see how it plays out. n to the 3, so how do you get there? Let's go here. Let's focus here. N cubed plus n squared versus just n cubed. I'm going to kind of do this in 2 steps, do the square root second. I get myself confused if I try to do too much at once. All right, so that's true because n squared is positive, right? This must be true. And so it would also be true that if I square rooted both sides, the inequality would hold true. And when I flip, I'm getting exactly what I'm hoping, which is this comes out less than. And so I feel like if you keep going with that, you're good. Okay? All right. 15. Did I cut this away? Oh, 15. Oh, yeah. Okay. 15. So the ratio test we're fine. The root test, I don't even know. Actually, let's go here. So we're trying to prove
No, I said Joe likes to discuss.
this comes out inconclusive for both tests. The right way to prove this converges or diverges is the integral test, is the classic way. But if we tried the ratio test, the limit as n goes to infinity here comes out to be 1 over n plus 1 over 1 over n, which is n over n plus 1. That does approach 1, and that is an inconclusive ratio test. So that's what I was looking at you showing there. The root test also is inconclusive if the limit comes out to be 1. So you take the nth root of 1 over n. This, I wasn't sure what to make of this, but this is, okay, so this goes to how detail-oriented are you? What is this limit?
One.
You want it to be 1, but it is 0 to the 0. And so, yeah, it's not 1 yet. It's indeterminate. So how should you be doing this? If you're doing this correctly, you should be using this approach to show it is, or find the limits. What?
Wouldn't you bring the,
Yes, sorry, I should have probably done that first.
No, you did a good job. This one. Let's switch on to that.
Sure.
do like 1 to the 1 over the n over n times 1 over n, right?
1 to the
1 over n
1 over n
over n.
over n to the 1 over n. That's still infinity to, it's still indeterminate. I hear you're trying to get around doing the indeterminate one, but it's
Isn't the nth root of 1 just 1?
nth root of 1 is just 1, but the nth root of n
Is
is
1. When that goes to infinity, doesn't that go to 1?
yeah, you have to prove that, don't you? I mean, we did a little table of stuff, yeah?
I thought that was so we
That's a
could
proof.
use that.
It's just you telling us that that's what it is.
Do we have to prove that?
I feel like, yeah, you should.
I feel like that should just be
Well,
like,
it doesn't matter what you feel, that's what I feel. I'm in
how
trouble.
are we gonna prove that?
Well, we're proving it right now, it's right here, see?
Looking
I
funny,
know,
Joe.
So, and
it's indeterminate and you must show it, that's all it is. But, and I don't feel like paying my taxes, but I do it. N goes to infinity of log of 1 over n, log of 0, you go for it, you see it. I will. I'll do it, I will enjoy doing it, actually, I think I will. I actually don't enjoy it now, but I will in the future.
Stickers.
Now that I know you're willfully choosing to do it badly,
I'm not doing it badly if I believe it.
believing it doesn't make it so.
I feel like the nth root of n equals 1 should just be
Believing it doesn't make it so. Oh, this goes there. Let's call that. That's nice, huh? This is e to the 0, which is 1, and that's inconclusive.
okay, what's up?
Boom. All right. That was fun, huh?
We got the same answer, we did it in like a quarter of the time.
Yeah, but you made it up. Mine's Raiders. 12, yes?
If you never said that 1 equals 1, that's bad work.
Yeah, why would you tell that us in class if we not allowed to use it?
Proving that as 1 is inconclusive. That's the theorem.
That's bad work.
Well,
You have to say that 1 equals 1.
You never said that 1 equals 1.
Or else you're going to only have
Yeah,
credit.
you told us that the nth root of n.
I feel like this has to be said. Do I have to say this?
Yes, yes. It's
I don't
exact
feel like,
same thing.
no, I feel like it's
Can
not.
we just go on to number 12, please?
No,
Okay.
we have to send.
Yeah, that's funny. 12, 12. 12, yes? Okay. This guy. I don't want to integrate that. Actually, you can integrate that by use of, and that wouldn't be bad. But I think a comparison test would go better. And what did you compare it to? N minus 3?
Wait,
I would compare it to 1 over.
yeah.
Yeah? Or n over, root n over n, is that what you're saying? Okay, sounds good. All right. That then is diverging, so my hope is that this will come out to be more than diverging to prove divergent, right? All right, so let's go there. First of all, I think you'll agree that n minus 3 is less than n. Yes? And n minus 3 over root n is still less than that. And the reciprocal is greater than that. And the sum is still greater than the sum. And this, by the way, is 1 over n to the half. And so I established that the one they ask about is greater than something that's infinite. So I could conclude that this diverges because it is greater than 1 over root n, which diverges. P series P equal 1/2 S. Boom. Yes. It feels like you should just pretend it's due tomorrow.
Are we turning it in tomorrow? Are we gonna have homework?
Should we turn it in tomorrow?
Are we gonna have homework?
Yes, should we turn it in tomorrow or have it today?
Okay, if I turn it in tomorrow, I'm not gonna have it.
What's that?
Mr. Rickman,
It's not up to you. It's up to you.
Yes.
Okay, my answer is the worst.
It's up to
I
you.
heard, yeah, just say Monday. I heard it come out of his mouth.
You told me here, so you can come on.
I heard it.
Yeah, he did.
Now, go. Have a nice day. Yep. No. There will not be homework tomorrow. There will be an in-class AB test.
We give another AB.
That's what it says.
No, it's 3 parts to one test.
I still feel like you have to say it's 1 equals 1 because that's the test.
No, I feel like the theorem says if the limit equals 1, then diverge. I showed the limit equals 1, therefore diverge.
Well, can't you then assume 1/2 is less than 1?
No. You can assume 1 equals 1. You can't
I
assume.
can't assume 1 equals 1.
You need to state what happens.
I just feel like that's the test.
In your lesson yesterday, you literally were like, you're like, that's the full text. If you don't have it, I don't think of it. And I was like,
But I proved it's equal to 1.
well, we proved it the other day, so why can't we just write one now?
So when you get, so listen, when you get the limit is 1, have you said, or sorry, 1/3, did you prove the theorem? The theorem
No, you
says
need to write
if the
it's less
limit,
than 1.
exactly.
And so
But if you-
1, what is it?
The theorem is, that's ridiculous.
I'm gonna ask Cindy.
Did you do anything to me? Get that jerk for that indeterminate thing.
I just think if I write 1 equals 1, are you going to be like, no,
Redundant is what I'll write.
no, you won't already?
Yes, I will.
Mark off.
I kind of feel like I should. You're wasting my time.
Mark off.
It's like marking off. When
I guess you said something that's true.
Mr. Rickman,
Yes.
can you require me to sign up to Alpha Theta with your full?
Okie dokie.
You Alpha Theta, what a loyal member. I appreciate you going out.
Yes.
So you were full, can you require me?
Walk around.
Only if you need help. If it's full, it's full.
I could use some help with my test corrections.
Okay.
Do a whole lot more than that. Thank you.
You're welcome.
Do a lot.
Yes.
So I was gonna finish a sentence to make up.
like
I remember this one kid
quiz
in
thing,
that.
but unfortunately I
Like he felt touched.
AP paging meeting.
He just sent
However,
the math
I don't have
forward.
a 6th hour, so can I just do it right now?
You're welcome, have a good day.
Man.
It depends on if I have it at the ready or not, I'm not sure. What is it?
Thank the Lord I don't have to do the homework tonight.
18 word.
I don't have to do the homework until like Sunday night.
Let's see.
Why not?
Hey,
Would it help if I sat on this side and you sat here?
go back my hand.
You should do it. You know, I'll sit on that side and you'll sit in the middle. And
Nice curve.
No, we should just all.
This one actually I could let you take. This one's not.
There's like 4 seats on this side.
So you want to displace everyone who's been sitting in those
I don't
seats?
know, because you're in the kind of,
This one I'm sitting now. That's what I had you chasing, but it's not any class.
I mean, as long as I get
I actually did it there.
All right.
I guess you take out.
It is a radio calculator.
Fire me,
Yes.
so it's like you walk
Praise
in.
the heavens above. They have blessed me with
That's what you
riches
have to
of
play
ice
today, so we
dust.
can present to everyone else today.
Probably like. Wait, no, someone erased already.
No, I saw you. I said
No. Who did that?
no, Sarah Moore got that.
Someone has to sit. You have to sit on our No, I'm not hot. I just like like take off, but I
Can't see his pencil in there.
All right. Hello, there's no. All right. Here we go. Warming up. Just asked me to require that.
Anyone not have a
Oops.
seat?
Everybody have a.
Oh, yeah.
All right. Sorry, there. It's coming up. You're having a lovely day. Okay, 18, 17, and 13.
No, shush. Isaac, your teams are in now. Oh, sweet. Science is so